So I'm going to show you how to do that. But before I start, if I just have you guys look at this very first question, I have x cubed minus 5x squared minus x plus 5. How many answers should that question have? 3. Okay, so I need to have 3 answers to this question. Now, they could be real, they could be imaginary, and it's just going to kind of depend on the question. So if I've got 4 different terms here. I don't have a method for factoring this. So what I'm going to try to do is I'm going to try to look at the related graph. So basically what we're going to type into Desmos is just exactly, I'm just going to type in the y equals this exact polynomial, and I'm going to look for the zeros or x-intercepts, just using the graph, and then we'll go from there, and I'll show you how to break it down based on that. So let me see if I can I'm going to pull up my Desmos. So you guys pull up your Desmos if you don't already have it up. And I'm going to see if I can pull it to the side so I can actually see the equation while I do this here. So I'm just going to write y equals x cubed, and then minus, to get an exponent you do shift and 6 if you forgot that, and 5x squared, and then I've got minus x, and then I've got plus 5. Okay, and then remember, I know this is a little weird, but just kind of use your fingers a little bit. Try to grab onto the y-axis or grab onto the x-axis. I'm going to move this so I can just scrunch it a little bit, maybe just so I could see the graph a little bit better. And I'm looking for zeros here. So crosses the x-axis at -1, crosses the x-axis at 1, and crosses the x-axis at 5. You can actually just click on the points and it'll show you that exact value there. Those are all nice numbers. It's not some gross decimal. Am I done with this question, with this graph? Spoiler, you actually are, because how many answers am I supposed to have? How many answers do I see on that graph? So I have all 3 of them. I don't have to do anything else here. So I'm actually just done with this question right now. And my 3 answers, you can plug them in to check. -1 is an answer, 1 is an answer, and 5 is an answer. Those are just the zeros. That's all you have to look for. So if I'm supposed to have 3 answers and I can get 3 answers off the graph, we're done. Now, they have to be nice numbers. If they are not nice numbers, I'm going to show you a little something different to do with that. But that question, we're totally done. I don't have to do anything else. Now, the question underneath here probably won't be so easy, but again, the highest power, whatever your highest power of x is, this is the same as the last one, is 3. So this question should also have 3 answers to it. All right, so I'm just gonna, same thing I did over here, I'm just gonna type this into Desmos so we can look at the graph, and if we can find any zeros here, they might give us all the answers, or it might help us at least break down the polynomial. Okay, make sure I typed that correctly. Yes, I did. All right, now if I come back, and you guys are probably looking at your graph too, I'm gonna just kind of stretch it out so I can see it a little bit better. All right, now I can see zeros on here, right? So if I click on that, if that gives me a nasty number, you cannot use that, okay, because I want an exact value. So it's either going to be in radical form, or if we don't actually see it cross the x-axis, it'll be an imaginary answer. But at least one of these is a nice number, right? I have 3. I can see 3. The other 2 are not nice numbers, so I don't want you to write those down. But I have 3 on the graph as an answer. And I need 2 more answers, and I can see what they are as decimals on the graph, but that's not going to be an acceptable format. So this is what you want to do. If I know 3 is one of my answers, right? 3 is one of my answers. What factor, so like a little set of parentheses, what factor would go into that polynomial? If you know 3 is one of your answers, what factor would go divide evenly into that polynomial? Exactly. Okay, so here's what we're going to do. We're going to take our nice answer, which was the 3. So that means x minus 3 has to be a factor of this polynomial. If something's a factor, you can use that to break down the polynomial because it will divide into the polynomial evenly. Okay, so basically what I'm going to do is I'm going to break this polynomial down into factors using that information from the graph. So totally up to you. If you guys want to use long division or if you want to use synthetic, I'm just going to use synthetic on mine here real quick. So you can use the 0 in the synthetic, or if you want to look at the factor there, it's the opposite of what it looks like in the factor, or you can just use the 0. So we'll just do a little bit of synthetic division here. So write down your coefficients. So I got 1x cubed, negative 3x squared, negative 2x, and then just 6 is my constant. We're not missing any powers of x, so I don't need to fill in any zeros or anything. All right, now I know it's been a couple days since we've done this, so once you set this up, you're just going to bring down whatever that first coefficient is for this question. It's 1. We just copy that underneath the line, and then everything else we're just going to multiply, add, multiply, add. So I take 3 times what's below the line, and you write it in the next open spot above the line. So 3 times 1 is 3, and then you add the terms that are stacked on top of each other. So this is a little bit weird because I get negative 3 plus 3, so that's actually 0. Now, don't be stupid like me. I do this all the time. So 3 times 0 would be what? Okay, a lot of times I write 3. I don't know why, but anything times 0 is 0. So then add these guys. This would be negative 2. 3 times negative 2 is negative 6, and that's what we should see, because if we got that from the graph, I know this is supposed to divide into the polynomial, so you should not have a remainder. If you have a remainder, you may have set something up wrong. Okay, so no remainder. And then the negative 2, that's going to be my constant term, my plain number. 0 would be x, and then we start adding powers of x, so it would be x squared. So who can, just raise your hand, tell me, like, how would you write that answer? What would that factor be? What do you think? Exactly. Okay, so here's the deal. I divided in, right, x minus 3, and what we just got x squared minus 2. So that's actually the factored form of that polynomial, right? So this polynomial, we're just breaking it down into its factors using division. We already saw one of our answers was 3 just from the graph. Now, it's going to depend on the problem, but for this one, this is really similar to some of the stuff you saw yesterday. If that is equal to 0, that'll set the whole thing equal to 0. So just from yesterday, do you remember doing this? Just, I'm going to do x squared minus 2 equals 0. This will give us our other 2 answers. I'm going to add 2. And when I do that, we're going to have to take the square root to get rid of the x squared. And I automatically, remember, get 2 answers out of that because I get the plus and minus square root of 2. Okay, now, just so you guys can see this, I'm going to grab my calculator real quick. And maybe I'm going to show you this. I don't know. We shall see. Let me see if I can make that readable. I'm just going to do, on my calculator, the square root of 2, just so you guys can see the decimal. Okay, there's the decimal for the square root of 2, right? Let me go back to that graph. It's 1.414, blah, blah, blah. So do you guys remember from the graph, the Desmos is just rounding that, but that's what these 2 answers are. That's your square root of 2 right here. This one's your negative square root of 2. But we're not going to take those decimal answers on a test or quiz. I want the exact answer, so I would want that square root of 2 and negative square root of 2. Is anybody having a question? Okay, let's try another one here. All right, so this one, again, we're going to use Desmos. We're going to graph this related polynomial, and this guy, x to the third, is the highest power, so I need 3 answers to this question. All right, let's see if we can graph this. Pull this over so we can see it. And I usually just kind of edit what I already have if I can to make it less work, so you guys, you don't have to totally retype the question or anything like that. All right, make sure I typed it right. And I'm going to scrunch my graph so I can see it a little bit better. Okay, so I'm supposed to have 3 answers, right? Okay. I only have one place where that touches the x-axis, right? I have a 5. So I know 5 is one of my answers. So I have to get 2 more answers. If you're looking at that graph, what is that going to mean about my other two answers if I only touch the x-axis once? Exactly. Okay, so this means the other two are going to have an I in them because we don't have a place where the graph intersects the x-axis again. Okay, so we're literally just going to repeat what we just did, right? But the other two answers to this, we're not going to be able to see them on the graph because they're going to be imaginary. So let me go back to this. If you have 5 is my answer. So the linear factor that'll definitely go into this polynomial would be x minus 5. To set that up, it's just what would you plug in to make that 0? So if I plugged in that 5 for x, that's how you get the factor. So it's going to kind of look like the opposite of what the actual 0 is from the graph. You're just going to do synthetic or long division. If you like long division better, please do that. So you can use the 0, or if you're looking at the factor, it's the opposite of what the factor looks like. And write down your coefficients if you like the synthetic. So you got 1x cubed, negative 1x squared, negative 15x's, and negative 25. After you set it up, the very first step is just to literally copy that first x, or the first coefficient underneath the line, and then the entire process is just going to be multiply, add, all the way down. But you got to bring that first number underneath the line so you have something to multiply. So I'm going to do 5 times 1, that goes in the next open spot. And then, let's see, add that to negative 1, that will be 4. 5 times 4 is 20, and plus a negative 15 there is going to be 5, and then 5 times 5 is 25. And this is what we want because we should not have a remainder. Okay, now, in this case, your plain number, your constant is the 5, it'd be 4x, and then 1x squared. So I'm just going to take a second here. The factored form of this polynomial, we got the 5 from the graph, so that would be x minus 5. Okay, our other factor here, we have x squared plus 4x plus 5. All right, now we know from looking at the graph, the other two answers have to be imaginary. So I'm not going to be able to factor this. I know this is a little bit tricky, and it's at the very top of the page of notes if you want to look at it. But if that's the case, what you want to do here is just go ahead and use the quadratic formula on this to get the other two answers. If you really wanted, if you liked completing the square, you could complete the square on this, and it wouldn't be bad to do because the b value is 4. So if you like completing the square better, I'll be happy to show you guys how to do that. I'm just going to use quadratic formula on my notes here real quick. So I'm going to do opposite of b, be negative 4, plus or minus, square root, 4 squared, 4 times 1 times 5, everybody over 2a, so it'd be 2 times 1 for this question. So usually what I do, just grab my calculator, I'm going to do what's under the square root. So 4 squared minus 4 times 1 times 5 would be, bless you, minus 20. This will be nice for us. So I get negative 4 plus or minus the square root of negative 4, everybody over 2. What is the square root of negative 4? 2i. So this is really negative 4 plus or minus, perfect square in imaginary land, so we're not going to have a radical there, everybody over 2. And these are imaginary, right? I got an I, that's what we expected from looking at the graph. Can I simplify negative 4 plus or minus 2i over 2? Gavin, what do you think? What would you write? Perfect. As long all three of these have to be divisible by 2, you just do negative 2 plus or minus. This would actually just become 1i or just I. They're not going to put a 2, or they're not going to put a 1 in front of it. So that's 2 answers in one because of the plus and minus symbol. And then our third answer was the 5 that we saw from the graph. Is anybody having a question? Okay, this is not terrible, but it all kind of hinges on you guys using the graph to kind of help you break down the polynomial. Okay, now Ms. Scrody has 2 mean questions on the back of this. All right, so these are huge, long, drawn-out polynomials here to the 4th power. So this question and the question on the bottom part of this, I should actually have 4 answers, okay? Now, I'm just going to literally do exactly the same thing. I'm going to try and Let me slide this to the side so I can try and put that on the screen while you guys look at the Desmos here. But so I'm going to type into my lovely Desmos, and I have x to the 4th, and then I have minus 10x cubed plus 19x squared plus 40x, and then minus 92. All right, so 4th degree, so both ends should go up if you guys are looking at the end behavior here. And they do. Okay, bless you. Are all my answers here real, or are some of them imaginary? How many answers? We're supposed to have 4, right? How many answers do you see on that graph? 4. You see 4 zeros on that graph. They might not be nice numbers, but all 4 of these answers are going to be real numbers. All right, so I'm just gonna kind of go like as close to the x-axis at your 0. If you just click on those points, they'll tell you what they are. And as I go across there, I see 2 of them are nice numbers, and then 2 of them are not going to be okay because they're decimals. So I've got 2 answers I can see from the graph. All right, one of them is -2, and one of them is +2. The other 2 answers, I can see them on the graph, so I know they're real, but since they're decimals or what I'm looking at there, that's not going to be an answer. We want an exact value. So it's not imaginary, but it's going to have a square root in it is what the deal will be. Okay, now here's how you do this. I actually know 2 different factors that will divide into this polynomial from looking at that graph. So if -2 is one of my answers, then x plus 2 is a factor that's going to divide into that polynomial. And if 2 was one of my zeros, then I also know x minus 2 is going to divide into that polynomial. All right, if you guys, I didn't really read this to you at all, but if you look at the actual title of the example, it says right in here, you're going to double divide. All right, so basically I'm going to break this polynomial down, and we're just going to do the process. You can use synthetic or long division, but we're going to do it twice. It does not matter which one of these factors you start with. Okay, it doesn't matter. You could start with the -2 or the +2. It doesn't matter. I am going to start with the -2. That does not matter, but that's the one I'm going to start with. I know x plus 2 is a factor of this polynomial. So if I divide, use synthetic or long division, completely up to you. If I divide, we should not have a remainder. Okay, so I have 1, -10, 19, 40, -92. I'm not missing any powers of x or anything like that, so I don't need any zeros. And I'm just going to bring down that first term and copy that below the line. Okay, everybody else, we're just going to multiply, add all the way down. All right, so -2 times 1 is -2. If I add that to -10, we'll get -12. -2 times -12 is +24. And then we're going to add that. I think that's 43. I'm just grabbing my calculator just to check. This will be 43. -2 times 43 is -86, I'm pretty sure. And then 40 minus 86 is going to give us -46. And this will be nice for us because I know I did it right. -2 times -46 is 92. So then we don't have a remainder. All right, so I divided in the x plus 2. Okay, does anybody know what you should do from there? I'm going to divide again, but like, how would you do it? Would you start over with the original polynomial, or what would you do? What do you think? Exactly. Okay, so we didn't use the 2. So you just literally, I'm going to use this exact thing. I'm not even going to write it out. You're just going to use that with the other 0. In this case, I'm going to use, I used the -2 first, so I'm going to use the +2 second. But you just literally copy down your result that you just had. Or you could, if you want to just write it right with that, you could just create it right above there. So I'm going to bring down 1. Okay, and then just repeat the process. So 2 times 1 there is 2. I'm going to add that to negative 12. So that's going to give me negative 10. 2 times negative 10 would be negative 20. I'm going to add that to 43. So that's going to give me 23. And I know I did this correctly because 2 times 23 is 46. And then we don't have a remainder, which we should not have because both of those should divide into that polynomial. So you're just breaking it down twice. All right, now, this remainder, we didn't have one. So the 23 is your plain number, your constant. Your negative 10 has an x, and the 1 has an x squared. Okay, now I only got 2 factors from the graph, right? So the total factored form, based on what we just did, we have x plus 2, x minus 2 from the graph. And then once we did our division here, we get x squared minus 10x plus 23. And that's as far as we could go because the other answers that we saw in the graph, they were not nice numbers. So we're going to have to use quadratic formula, or if you want it, I'll tell you what, I'll do completing the square on this one so you guys can see that if you want to do that. So we got the 2 answers, the negative 2 and the 2 from the graph. If you guys want to do quadratic formula, do quadratic formula. If you want to do complete the square, I'm just going to remind you how to do that real quick. If I set this equal to 0, x squared, it'd be minus 10x. And I'm saying I could use completing the square here because that if that b value is even, it's usually not too bad to do. So I would leave a little space, and I'm going to put that 23, I'm going to set that as negative 23 because we would set it equal to 0, but you'd move the plain number to the other side if you want to complete the square. If you want to do quadratic formula, do quadratic formula. All right, I'm just giving you another option. To complete the square, you take the b value divided by 2 squared. That's why I thought it might be okay for this one because my b value was even. For this question, that would be negative 10 over 2 squared, which is negative 5 squared, which I know that's a lot of work, but that would be 25. So I'd add 25 to both sides. Now, whatever you squared, I squared negative 5, that should be the factor. So this is completing the square. The 2 factors are the same. Multiply to get 25, add to get negative 10. It'd be x minus 5 times x minus 5, or x minus 5 squared. Then this side is just 2. Negative 23 plus 25. All you got to do, if you're completing the square, get rid of the squared by taking the square root here. Now, when you enter the square root into the problem, that automatically is going to give you that plus and minus symbol. And then I would just have to do one more quick thing. I would just have to add 5 to the other side of that. And I would just put that directly after the equal sign, be plus or minus square root of 2. So that's 2 answers in 1. Okay, so I'm just going to show you guys real quick because we had the graph. If I do 5 plus the square root of 2, just to show you the decimal, and then I'm going to do 5 minus the square root of 2, just to show you the decimal. So I've got like 6.414 and like 3.586. Okay, let me go back to the graph. See that 3.586 and 6.414. So that's what Desmos is giving you. We just want it in that exact format. So then you got 2 options. You can always use the quadratic formula. If your b value in there is even, you want to complete the square, whatever's easier for you. Okay, so we just have one more. This one's like really long, bless you. This one should also have 4 answers because you've got x to the 4th as your highest power. So this should have 4 answers again. And each one of these questions was just a tiny bit different. So let me go back over here. All right, so I've got x to the 4th, I already have that, plus 6x cubed, and then I have plus 69x squared, 384x, and then plus 320. And I'm going to move this a little bit. And it almost kind of looks like a parabola, but it's to the 4th power. Now, if I look at this, I automatically know I'm supposed to have 4 answers. How many answers can I see on this graph? 2. So that means the other 2 have to be imaginary. Okay, so I think both of these are nice numbers. So we're just going to grab those 2 nice numbers off the graph. But in this case, my 2 answers are going to be imaginary. for my situation here. Okay, so we got -5 and -1. Does not matter the order that you do this, but you're going to double divide. So if -5 is a 0, that means x plus 5 would be a linear factor that'll divide evenly into that polynomial. And if -1, we saw that on the graph too, is a 0, then that means x plus 1 is another linear factor that'll divide into this polynomial. So we're just going to use that twice to break it down. So, all right, it doesn't matter which one you start with. I'm just going to start with the -5. All right, so I'm writing down 1, 6, 69, 384, and 320. And then I feel free to use your calculator. Some of these numbers are really big, but you just bring down that first term. And I'm going to multiply, add all the way down. So -5 times 1 is -5. I'm going to add that to 6, so I'm actually just going to get 1. -5 times 1, -5 again. We're going to add this. We're going to get 64. 64 times -5 is -320. And I'm going to subtract that from the 384. You'll get 64. And then 64 times 5, or sorry, -5 is -320 again. So those cancel and I don't have a remainder. Now, since I had a second 0 from the graph, just right from there, I'll just do a different color. I'm going to use the other linear factor, x plus 1. The 0 is -1. And I'm just going to copy what I just got. I got 1, 1, 64, 64. Just repeat the process. And again, if you got these off the graph, when you divide, they should not have a remainder. If you get a remainder on these, then either we set something up wrong, or we copied something wrong, or made a little bit of a mistake of some kind. So, 1. Okay, -1 times 1 is -1. When I add these, this actually becomes 0. Okay, and then make sure you're multiplying. I always screw this up. -1 times 0, anything times 0 is 0. This gives me 64. And then -1 times 64 is -64. I don't have a remainder, which I should not. Okay, so 64, plain number. I don't have an x. This will actually be nice for us. If I'm missing that, that's going to mean we're going to be able to use square roots if we want to. This will be x squared. So my completely factored form, as far as I could go down, we'd have x plus 5. X plus 1, we got those two factors from the graph, and then once we did the division, we're just going to get x squared plus 64. So I'm supposed to have 4 answers, right? And I know 2 of them are imaginary because I could only see 2 on the graph. So -5 and -1, we got those from the graph. If you want to just do what we did yesterday with square roots, if x squared plus 64 was equal to 0, the whole thing would be 0. We're just going to subtract 64. And it's negative, but we know that from the graph that these should be imaginary. What's the square root of 64? 8. So -64 is the perfect square in imaginary land. So you just write this as plus or minus 8i. And there's your other 2 answers. That plus or minus gives you 2 answers in one. It's 2 different answers, positive 8i, negative 8i. Is anybody having a question? If you guys do want to go back and check any of your answers, and you can do this with the imaginary answers too, if you have a graphing calculator. If you have a scientific, I don't know that it has this button, but I'll show you this real quick, just if you want to check your answers. If you guys have not seen this, where's it at? If you look at the decimal point button on the graphing calculator, the second function on that is actually an I. And that is I, like the imaginary number I. So if you wanted to check this, you totally could. See if I can make that a little darker so you can read it. But if I did, I'm just using second and then the decimal key. I'm going to plug in, no, I will slide to you. I'm going to plug in 8i everywhere I see an X, just to show you. You can check this. This would be to the 4th, and it'd be 6. I'm putting in 8i. Just hit second, the decimal place, to get the I on your calculator. That's to the 3rd. I'm just checking this. Then I have 69 times 8i to the 2nd. And then I have 384 times 8i. And then I have plus 320. And then it's going to write it in imaginary format, but 0 plus 0i is just 0. So then that way I can check and make sure that made the equation true. So if you want to check any of these, and you could do that like back here with the 5 plus the square root of 2. I would just, in the parentheses, just put 5 plus the square root of 2, and then you can plug it into the polynomial we had up here in example A. If you want to check any of these, you can do that. Whether it's real or imaginary, you can plug them back in to check your answers.